My name is Kristen Thorson, and I'm the Manager of Research and Development here at REGENESIS. And in that role, I lead a great group of scientists on the development of new remediation technologies, and we also provide technical support throughout the company and for our clients. REGENESIS has been developing new remediation technologies for over 20 years, and in all those cases, the technology has started in the lab with various testing to understand its efficacy and how it works. PFOA and PFOS are abbreviations for two chemicals with full names perfluorooctanoic acid and perfluorooctane sulfonic acid. While not used anymore, PFOA and PFOS were used in various industrial processes and are also components in numerous manufacturing and consumer products. The reason why they were used in these types of products is that they imparted many useful properties, including being thermally stable, and they did not biodegrade. So overall, they were very robust chemicals. These chemicals have made their way into the environment and have been detected in groundwater, drinking water, and soils. And the concern here is when they are in drinking water, they offer a potential exposure pathway for humans. Once PFOA and PFOS are released into the environment and reach the groundwater, they can readily spread, forming very large and dilute plumes. The result of this is a widespread problem that can be very difficult to clean up. In the case of PFOA and PFOS, the EPA has set a very low standard of 70 parts per trillion. And this is actually revised recently in 2016 to be even lower than what the previous limits were as established in 2009. In 2014, we released a new product called PlumeStop Liquid Activated Carbon. One of the key attributes of PlumeStop is its ability to distribute activated carbon under low pressures in the aquifer. In order to achieve this, we ran several hundred soil columns in order to test the transport as we optimized the formula. In the case of PFOA and PFOS, this is useful because we now have a method for in-situ plume containment. This unique formulation allows PlumeStop to be injected into the ground under low pressures without fracking and have it distribute widely into the same flow channels where water is moving. Unlike many remediation technologies where the efficiency decreases with decreased concentrations, PlumeStop actually increases its efficiency at low concentration, which is really important because it allows us to meet those types of low standards that the EPA has set. As we do with any contaminant to be treated with PlumeStop, we measure the isotherm for that contaminant in order to understand the dose response. In the case of PFOA and PFOS, we have run those modeling studies and shown that a single dose or single barrier of PlumeStop could be expected to last for even 10 years. And we can always increase that by increasing the dose or adding in multiple barriers. Emerging contaminants like PFOA and PFOS, which we're finding are very difficult to treat with our existing technologies, are causing us to refine the way we think about addressing these types of contaminants.